Hi, welcome back to my YouTube channel. So let us see question number 7 from 2019. It says, determine the set of all points where the function f of x equal to x mod x is differentiable. Let's start the solution like this. Solution. We have the function f of x. So let us write it down this way. We have x mod x. So I can write this function as x square if x is greater or equal to 0, and this is minus x square if x is strictly less than 0. I can write like this. And here one more thing, the domain of the function is not given. If the domain and codomain of the function is not given, we will always consider the domain as the set of real numbers. So we will consider this function as function defined from R to R. So we will consider that our set of real numbers is our domain. Okay, now next line, let us take one x equal to c be any real number from the domain of f. So let us divide this problem into three cases. First case number 1, let c is equal to 0. So let us check what happens at c. So if c is equal to 0, so let us find the left hand derivative. If I find a left hand derivative, this will be limit x tends to, my c is 0, so I'll take 0 minus of x minus f of 0 by x minus 0. This will be equal to 0 minus, at 0 minus, I know my function value takes minus x square, so f of 0 will be 0, and here this will be nothing but x, simply x. So from here I'll be left with limit x tends to 0 minus x. I will get finally it will 0. Next, the right hand derivative will be limit x tends to 0 plus f of x plus f of 0 by x minus 0. So for x greater than 0, my functional value is x square, so this I will get x square minus 0 by x. That means this is tends to 0 plus of x, again we get this as 0. Therefore I can write left hand derivative is equal to right hand derivative is equal to 0, which is some finite number. This 0, I can say this is equal to f dash of 0. How? We have our function in this form. So if I write this, how I've written, since f dash of x is equal to 2x if x is greater or equal to 0, and minus 2x if x is strictly less than 0. From here I can say that when x is equal to 0, my f dash of 0 will be 2 times 0, that is 0, and this will be equal to nothing but limit f of x as f of 0 by x minus 0, x tends to 0. From here I can say that therefore f is differentiable at x is equal to 0. Now let us check the second case. Case number 2. Let c is strictly greater than 0. Therefore limit f of x as f of c by x minus c, x tends to c, will be, for c greater than 0, my f of x will take x square minus c square by x minus c equal to limit x tends to c by x plus c. So I will get this as twice c, which is nothing but my f dash of c. How? From here, because f dash of x equal to 2x if x is positive. So since my c is positive, so my f dash of c will be 2 times of c from here. So from here, what can I say? I can say therefore f is differentiable at x greater than 0 points. Now case number 3. Let c is strictly less than 0. Then limit f of x minus f of c by x minus c, x tends to c, will be limit x tends to c. Now since c is negative, so my f of x will take minus x square, and from here my f of c will become minus c square. This will be x minus c. This will be limit x tends to c. If I take minus common, so I will be left with minus x square minus c square by x minus c. So this is nothing but limit x tends to c minus x plus c is equal to minus 2 times c, and this I can write, this is equal to f dash of c, because for c negative, my f dash x takes the value minus 2x when x is negative. So my f dash of c will be minus 2c because c is negative here. Therefore from here, what can I say? I can say therefore f is differentiable at x strictly less than 0 points. So I can conclude that since c is arbitrary, therefore I can say that f is differentiable for all x belongs to R in the domain of f. Therefore I can say that my required set will be, what was my question? My question was determine the set of all points where the function is differentiable. I have checked that this function is differentiable at x is equal to 0, x is strictly greater than 0, and x is strictly less than 0. That means I have shown that my function is differentiable for all points on the real number. And since I have considered that my domain is set of real numbers, so I can say that The set of all points where this function is differentiable is nothing but the set of real numbers. So my required set will be nothing but the set of real numbers, which is my required answer. Thanks for watching.